Here we are working on day 2 of section 7.3, working more with identities and solving these math puzzles. But here we have an example E. We have two fractions that are added together to get a single term. So thinking of, since I want one answer, I'm probably going to want to combine these fractions, and to do that I'm going to need a common denominator. And in my common denominator I need a factor of 1 plus cosine of theta and a factor of sine of theta. Now each of these individual fractions were missing a factor of the denominator. So I'm going to multiply each ratio by the factor that's missing. So on this denominator, I'm missing the sine. So I'm going to multiply by sine of theta on top and on bottom. And on this side, I'm going to multiply by 1 plus cosine of theta to the top and bottom of that fraction. All right, so for each of these now we have sine theta and 1 plus cosine theta. Now I'm going to multiply the tops, and I have sine times sine, so that's sine squared of theta. And over here I have 1 plus cosine theta times 1 plus cosine theta. So that's going to give me 1, okay, and I'm doing FOIL here, plus cosine theta plus another cosine theta, so there's 2 cosine thetas here. And then cosine times cosine is plus cosine squared of theta. So looking at the top, and if I can maybe combine like terms, or if I see anything special here, well, I do see a sine squared of theta plus a cosine squared of theta, and I know that these together add up to be 1. So I'm going to substitute a 1 in for sine squared and plus cosine squared. So this is 1. And then I have a plus 1 plus 2 cosine theta. My denominator stays the same. All right, so here I'm just going to simplify this instead of writing it out again. 1 plus 1 is 2. And I have a 2 and a 2 cosine theta, so I'm going to factor out that 2. So I have 2 times 1 plus cosine theta. And on the denominator, I have 1 plus cosine theta times a sine theta. And I just kind of line these up so that we can see that these are the same factors. So this gives me 2 over sine theta, or 2 times 1 over sine theta, and sine theta is cosecant. So I have 2 times cosecant of theta. Okay, so that's what I end up with, which is what I'm looking for right there. All right, so a lot of simplifying here. Now I see a single fraction, okay, tangent of v plus cotangent of v, and I have secant v and cosecant v on the bottom. Now I have a sum of things on the numerator, So since I'm going to, I'm going to add these together to get 1. So, but I'm going to break these apart. So I can do tangent of v over my denominator, secant v, cosecant v, and then I have plus cotangent v, which is over secant v, cosecant v. I'd much rather use just a theta. But now let's think in terms of sine and cosine. So tangent, I know, is sine over cosine. And on the denominator, I know secant is 1 over cosine, and cosecant is 1 over sine. So I'm going to divide this by 1 over cosine of v sine of v. Okay. And for the second term, I have cotangent, which is cosine of v over sine of v. And I still have 1 over cosine and 1 over sine as my denominator. So I'm still dividing by 1 over cosine v sine of v. And now we're going to look at each part of this separately. All right, so we're going to look here. And when I multiply by the reciprocal, I'm going to have sine v over cosine v times cosine v times sine v over 1. So I just flip this over, and now we're multiplying. But I do have some factors that can cancel. And here I'm just left with sine squared of v. So this is sine squared of v. Then I have the second part of this problem, the second fraction. And again, I'm going to multiply by the reciprocal. So I'm going to start with cosine v over sine v, and I'm going to multiply by the reciprocal, which is cosine v sine v over 1. Now this time I can cancel out some sines, and I'm left with cosine squared of v, and with the Pythagorean identity, sine squared plus cosine squared of the same angle is 1. And that's what I wanted it to end up to be. Okay, so those just kind of are the same thing. Last one. This time I have a fraction, and I want it to equal another fraction, but look how different the denominators are. So since I want to end up with a 1 plus sine theta on the denominator, the left side I'm going to multiply by 1 plus sine theta on top and bottom. Now remember, this is just 1, so I'm just multiplying this side by 1. And I don't want to touch anything on the left side. So if I have 1 plus sine theta and 1 minus sine theta, I'm going to end up with the difference of squares because these are opposites of each other. So I'm going to have 1 minus sine squared of theta. And then I'm going to multiply my denominators, and let's just see what we get here. I have 1 plus sine theta times cosine theta. Well, if I think about my sine squared plus cosine squared equals 1, if we were to have 1 minus sine squared of theta, or v, or theta, because we're working with theta now, but if I subtract sine squared of theta from 1, that's going to be cosine squared of theta. So this value right here is cosine squared of theta. So if I were to just keep the same denominator, notice I have a cosine factor on top and bottom. So I'm going to cancel one of the cosines on top, and I'm left with cosine of theta over 1 plus sine theta. And again, this is what I want it to look like. That's the same thing. So we were able to accomplish that. All right, so just a little bit more with practicing working with our identities.